3. Consider the function f equals to 1 over the lambda times x squared minus 2 lambda x plus 1. Determine the values of lambda, which is a real number, for which the function is continuous in two different sets, right? In R or in 0, 1. Okay, so let's start with R. So f of x, right, is a rational function, right? Because lambda is a number, so that means that this is a square, second order polynomial, and f will be continuous in the whole of the real line if there is no zeros here, right? So if lambda x squared minus 2 lambda x plus 1 is different from 0 in all R, in the whole real line, then f is continuous, right? Now, as you can see, there's two behaviors here depending on the value of lambda at first sight. So if lambda is equal to 0, this is not a second order polynomial anymore, right? This is 1, right? And so the denominator is 1. Okay, in fact the f is now a constant function 1, right? And so f is continuous, right? F is continuous in R. Okay, that's if lambda is equal to 0, right? If lambda is different than 0, then we have second order polynomial. We can try and compute its roots, right? Where is this going to be 0, right? So then we have x squared, we divide everything by lambda, right? So that we have minus 2x plus 1 divided by lambda, right? Equal to 0. Okay, so we can apply our well-known formula. This is 4 minus, and then 4 times 1 over lambda, right? Divided by 2. And so we can take a common factor here. This is 1 plus minus 1 minus 1 over lambda. Okay? Now, interestingly, we can actually rewrite this. You can see this is x squared plus 2x, minus 2x plus 1, right? X squared minus 2x plus 1, and then have minus 1 plus 1 over lambda, right? In order, we assumed plus 1 and minus 1, but this is a perfect square, right? This is x minus 1 squared, and then minus, or let's call plus 1 over lambda minus 1. Okay, this is equal to 0. Yes, this will be interesting later on, right? So now the roots of this polynomial are this, right? 1 plus this, 1 minus this. Now, if we want f to be continuous in all R, that means that this second order polynomial, or this parabola, has to have no roots, or in other words, that 1 minus 1 over lambda has to be smaller than 0, right? Yes, smaller than 0. So if this is smaller than 0, then there are no real roots of this, right? When is this true? Where remember to be careful here, because if you want to multiply by lambda, this will depend, this will change the direction of the inequality depending on if this is some minus, right? If lambda is positive or negative, right? So the easiest way to deal with this is to take everything in the same denominator, in the same fraction. This is lambda minus 1 divided by lambda is smaller than 0, right? Now if you multiply this by lambda, if lambda is negative, this is going to be change the sign, right? So in order not to make things worse, we're just going to see where is this going to be negative, right? In order for this to be negative, we have the numerator has to be negative, and so there's two possibilities, right? Lambda minus 1 smaller than 0, lambda greater than 0, right? Or lambda minus 1 greater than 0, lambda smaller than 0, right? So these two factors have to have different signs. Now, lambda smaller than 1, okay? Lambda minus 1 smaller than 0 is lambda smaller than 1, and lambda greater than 0, so this implies that lambda has to be in this interval 0, 1, right? Now, lambda greater than 1 and smaller than 0 at the same time is impossible, so this is the empty set, okay? So we've seen that if lambda is in this open interval 0, 1, the square, the parabola doesn't have roots, and also if it's 0, it doesn't have roots because it's not a parabola anymore, it's a constant function, right? So then, in order for f to be continuous in the real line, it has to be in this, lambda has to be in this interval, right? Close 0, because it includes 0, and then everything else in 0, 1, right? Okay, so now let me go for B, okay? So part B says f continues in 0, 1, right? So in order for f to be continuous in 0, 1, there are two possibilities, right? So it either has no roots, just like in A, okay? Or its roots are outside 0, 1, right? Because if the points of discontinuity of this function are only in the roots of this, but if the roots are outside the interval, then it will be continuous in that interval, right? So a way of thinking about this is that we have this parabola, right? Lambda squared x squared minus 2 lambda x plus 1, and again thinking that lambda is different than 0, because then it's not a parabola, and we have this expression, right? Our parabola is this, okay? X minus 1 squared plus 1 over lambda minus 1, okay? So this is just a parabola centered in 1, right? Okay, so something like this. And it will, the values of lambda will make it either go up, okay, or go down. This will depend on the values of lambda, right? And so, for instance, if lambda is, let's say, 1, for instance, right? So this is 1 over 1 minus 1, then we have this particular value, right? That our parabola is actually x squared minus 2x plus 1, right? Then if lambda is greater than 1, then this will be negative. 1 over something that's greater than 1 will be smaller than 1 minus 1. It will be negative, so then we have this, okay? So lambda greater than 1. And then if lambda is smaller than 1, then we have this, okay? Lambda smaller than 1, okay? So we've seen, right, that if lambda is between 0 and 1, it will not have, well, lambda has to be positive here, of course, yes, right? Because if lambda is negative, then everything changes. The sign of this changes, right? We can't do it like this anymore. This is a negative parabola, right? So so let's see. Well, we need our roots to be outside the 0, 1 interval, okay? So we've seen if lambda is different than 0, then the roots are this, right? Let me go here. Okay, so we have two possible roots. x1 is 1 plus 1 minus 1 over lambda, right? And x2 is 1 minus 1 minus 1 over lambda. Okay? And so you can see here, this is 1 plus something that's positive, right? Or you know, if there's no root, then this is not something. Okay, so this is 1 plus something that's positive. This is automatically going to be greater than 1 as long as there are 2 roots, right? So this is what's happening here, right? In this parabola, one of the roots is always greater than 1, but the other one is here, right? It's in 0, 1, right? So what happens? How do we say it? We need to enforce that this is smaller than 0, right? This has to be out of the 0, 1 interval, right? So when is this true? Let me see. So 1 minus the square root of 1 minus 1 over lambda has to be smaller than 0. So if we take this subtracting, we change signs, we have 1, the square root of 1 over, sorry, 1 minus 1 over lambda, it has to be greater than 1. Okay, in order for the square root of something to be greater than 1, the argument of the square root has to be greater than 1. So this has to be greater than 1. In other words, 1 over lambda minus 1 over lambda has to be greater than 0. Okay, and this implies that lambda has to be smaller than 0. Okay, so in order for f to be continuous in 0, 1, we need it to be to have no roots, so that lambda is between 0 and 1, or that its roots are outside 0 and 1. So that means that for b, lambda has to be in this minus infinity 1, okay, the union of these two sets. Okay, so roots outside 0, 1 or no roots. Okay, so that means that, you know, for every value of lambda that's positive greater than 1, you're actually going downwards here, and the greater, as you can see, the greatest, if you go to infinity, right, the greatest point that you can take this parabola downwards, right, this is 1, right, you take in this parabola downwards by increasing the value of lambda. Well, if the limit of this, when limit of 1 over lambda minus 1, when lambda goes to plus infinity, this is lambda and not x, right, the limit when lambda goes to infinity of this is 0, so the limit of this is minus 1. Okay, so the smallest thing that you can, or the lower point that you can take the tip of the parabola is this, right? But if this is true, right, our parabola has 2 roots at 0 and 2, okay, because our now parabola is x minus 1 squared minus 1 equals 0. Okay, so it has 2 roots, 0 and 2. So there's no way that you can get outside this interval 0, 1, sorry, in the roots by increasing the value of lambda. Okay, you're just making a parabola. Okay, if lambda is smaller than infinity, will always have a root in this interval, right? Now the other way around, what it's doing is that we increase lambda, right? We keep increasing up until when you get to 0, right? So when what's going to happen here is that the lambda is as you decrease it, your parabola gets wider and wider and wider and wider up until you get to 1. Okay, the value 1 in the horizontal, which is a constant, right? We just said when lambda is 0, this parabola becomes a constant 1. Okay, so I don't know how to plot this better than this. So when you go up, right, you enlarge, you widen the parabola. When you go down, you also make it wider until you can get no more than this when lambda is infinity, right? And what else? So yeah, and at some point when you go below 0, right, what's happening is that now the parabola is negative, right, and then you automatically go over the 0, 1 interval. Okay, so well, you can try and point in plotting this parabola for some values of lambda in your favorite software, but this is pretty much it.